Hi, welcome. We are doing our first set of notes for the second week right now. We are going to be doing radical expressions, which isn't really one of the early sections in the textbook. It's one in the back of the book because it's a review of algebra. It's a review of algebra, though, that's pretty important, so we want to make sure that we've got a strong foundation for it. It's notes number 1-4, which means quarter one, notes number 4. We like to date our notes, so I'm going to go ahead and put the date 8/31 and Monday 20. Okay, so hopefully a lot of this is review. Again, if you have any questions, make sure you contact us during office hours or during our class meetings. If a squared is equal to b, then a is the square root of b. Every positive number has two square roots, a positive and a negative square root. 0 only has one square root. The square roots of negative numbers are imaginary. So again, you can't take a square root of a negative number. So some things that we want to kind of pay attention to. I'm going to go ahead and do some stuff up here. Let's say we have 3 squared. 3 squared is 9. That means that 3 is the square root of 9. Okay. What are our square roots of 49? Well, square roots of 49, because every positive number has two square roots. The square roots of 49 are going to be -7 and +7. Because you have to look at it like this. The square root of 49, if I ask you this question, the square root of 49, square root of 49 means that answer would be 7. You want to give me the primary square root. The primary or the principal square root. I could ask for something like, what is the opposite of the square root of 49? And then you would tell me that answer was -7. If I asked you for the square root of -49, you cannot take the square root of a negative number, so this would be no real solution. Okay, so those are the roots that we kind of want to pay attention to. Square root of AB is the square root of A times the square root of B. The square root of A over B, you're going to kind of distribute that square root of A over square root of B. These are some rules that we should have known from last year. Now, if we want to find properties of radicals in this, those are our properties of radicals. We want to simplify these radicals down here. You want to look for some square root factors. And I talked about this the other day in my notes. First, you want to know your perfect squares. Every single time, you want to look for your best, your biggest perfect square possible. If you're not familiar with your perfect squares, I would say write a list of them. Everybody go ahead and pause your screen, write a list of your perfect squares out. 1 squared, we don't really need to write 1 because every number has a factor of 1, so we don't need to write that. 2 squared is 4, 3 squared is 9, 4 squared, 5 squared, 6 squared, 7 squared, 8 squared, 9 squared, 10 squared. I usually write a list of my perfect squares. I want to look for those as factors. Are one of these a factors of 50? A factor of 50 is going to be root 25. I'm going to write this as square root of 25. I like to put my perfect square first because I can take that square root times the square root of 2. So my final answer here is going to be 5 root 2. Now, if you remember the other day, we also did factor trees. I feel like that's extra work because I hope we know these numbers, but again, a lot of us like to use our factor trees, and if you are comfortable with it and you like to use your factor trees, go ahead. And 2 times 25, 5 times 5, that's where you get 2 of those and 1 of those, and you're going to do your factor tree and factor it that way. Here we have 4 plus 24. You're going to have to add those together first. It's kind of like when they're underneath the radical, it's kind of like they're under parentheses. So we're going to have square root of 28. Pause it. Simplify these if you can. What is a perfect square factor of 28? I check over here. The biggest one I have is going to be 4. So I'm going to rewrite this as square root of 4 times square root of 7. I can take the square root of 4, it's 2. I don't know the square root of 7. I can't simplify it any farther. I leave it under the root. Now this one here, what's interesting here is, are any of those perfect squares to begin with? Well, we have a square root of 24. I'm going to highlight this. And you're going to notice that I'm going to highlight that in the notes. This is going to show up again in our warm-ups and other problems. You want to pay attention to that. I can write this. Remember, I can kind of distribute that root. Square root of 2 over square root of 64. I know the square root of 64. So I'm going to write square root of 2 over 8. I want to simplify that a little bit more, but one's under a radical and one's not. I cannot simplify. I am done. Now this next one, I looked at the numbers. There's no perfect squares, but I can simplify it. Let's go ahead and simplify it right away. First I can divide by 10, and I get 3 over 15. But now I can simplify by 3. Divide by 3, I get square root of 1 over square root of 5. Okay, so hopefully remember this. Can you have a radical in the denominator? We are not allowed to have a radical in the denominator right now, so we're going to rationalize our denominator. And I have that down here in the notes. Rationalize the denominator. When we rationalize our denominator, we're going to multiply by root 5 over root 5. The reason this is nice is because anything over itself is going to be 1. I'm multiplying this by 1, not changing the value. Multiplying by 1 keeps the value the same. It's just going to change how it looks. Now, if it changes how it looks, then I'm not going to have that radical in the denominator anymore. 1 and 5, I get square root of 5. Now, hopefully we remember that root 5 times root 5, if you need to show the step, you can. 5 times 5, I get 25. That's a perfect square. That's where I'm going to get rid of that radical. So now I have root 5 over 5. And I can't do anything else because one's under a radical and one's not, so I'm done. Box in your answer. Hopefully, how many of us remember this? Hopefully we remember this. If not, you definitely want to practice this. We're going to have these showing up throughout the year. These are going to be important problems that you become really good with, so you're good with them in Algebra 2 and so forth. So keep that in mind. These are problems you don't want to just skip over. You want to know how to do that. Okay, so this one down here, again, I can't simplify. One's in a radical, one's not. I have a radical down here in the denominator. I need to rationalize. I like to do it with a different color, so I'm going to use red. Square root of 15 over square root of 15. I end up with 5 root 15. Now, 15 times 15, 15 squared, we're going to get 225. And we multiplied those together on purpose so we could take the square root, and so we have 15 in the denominator. Well, now I can simplify. The 5 and the 15 are both out of the radical, so I can divide that by 5. I end up with an answer of square root of 15 over 3. I know we really want to simplify. Remember, we cannot simplify here. One's under a radical, one's not. This is my final answer. You can't go past that spot. Okay, so hopefully we do remember some of those and we do good with those. Practice them. They're on page 799 in the back of the textbook. You want to be really strong with these types of problems. Okay, the next thing we're talking about today is solving quadratic equations. These are pages 800 to 801 in the back of the textbook. Again, this should be algebra review, but I know that last year we ended kind of wonky. So if we have questions, we can definitely go over different problems like with this, but hopefully go to the back of the book, look at those examples, practice those, see how we do. Okay, solving a quadratic equation, solving ax squared plus c equals 0. If b equals 0, we can extract the square roots, or if the x squared terms cancel, we can solve by the resulting linear equation. Be careful to distribute when multiplying binomials and to account for both square roots when extracting. What is the difference between these two things right here? They seem pretty similar to us. If I tell you that x squared equals 9, that means what could x have been here? So that means if I want to get rid of the square, I'm going to square root both sides. I'm putting the square root here. If I'm putting the square root here, that means that the absolute value of x would have been 3, the principal root. Well, absolute value means that it could have been a positive or negative. So technically here, x could have been, I'm going to highlight this. I like to highlight before I write it so it doesn't smear. X could have been either a positive or a negative 3. Okay. So if it just says x squared equals 9 and I'm going to put the root in there, that means I want both of the roots, either one that could have been there. If I'm asking it like this, the square root of 9, and I already have the root there, then I want you to tell me 3, because again, this is the principal square root. Okay, if it's already there, I want the positive root. If I tell you x squared equals 9, give me both roots. This again is going to be a problem that we have throughout the year. I believe almost every test we have all year, you're going to have a positive negative in it. You've got to remember where that's showing up. Pay attention to this problem. Go ahead and pause. We're going to go to the next page. So I didn't elaborate much on that paragraph from the last page, but we're talking about solving quadratic equations. Quadratic equations are when we have an x squared. If your highest exponent is your x squared, you have a quadratic equation. So usually it's in the form of ax squared plus bx plus c equals 0, as long as a does not equal 0. So we have some quadratic equations here, and we want to solve the equation or write an overall solution if that's the case. So there were some hints on that first page, and we may go back to that first page and I'll highlight or underline certain things that are important to pay attention to. We want to solve this. If I have 4x squared minus 200 equals 0, there's no x in the middle. I don't need to worry about factoring this. I have no middle term. That b term is 0. So if that b term is 0, I want to add 200 to both sides. I'm going to add 200 to both sides. I end up with 4x squared equals 200. I'm going to divide both sides by 4. X squared equals 50. Now, remember again, I have x squared here equals 50. I need to get that x by itself. I have to put in a square root. So if I have to put that square root in there, and I just did 50 on the last page, hopefully I remember what's happening here. I need to take the absolute value of x, which will be the square root of perfect square factor of 50 is going to be 25 times root 2. Now if it's the absolute value of x equals square root of 25 times 2, that means that x is equal to, hopefully you remember to put this there, paused it and worked ahead, positive or negative 5 root 2. Now, similar on the next problem. B is going to be a little bit similar. We want to solve for x squared, which means I want to get rid of that 3 first probably. So I'm going to subtract 3 on both sides. I end up with negative 2x squared equals 48. Now I have a negative 2 in front of that x squared. I'm going to divide both sides by negative 2. I end up with x squared equals negative 24. Okay, I need to put that square root in there. X squared, I'm going to get rid of the x squared. I'm going to square root both sides. That inverse operation of squaring something is going to be square rooting it. can you take the square root of a negative? So right away, I now know that this is no real solution. I put a fancy R for the real number set usually. And there we go. Okay, so every year when we get to this one, it's the first time we're seeing this year, it throws us off a little bit. I'm challenging everybody to multiply this, x minus 5 squared. Go ahead and write what you think that is. Pause it, write it out. Generally, we forget that if I have x minus 5 squared, that really what that means is x minus 5 times x minus 5 equals 3 plus x squared. So if you remember that paragraph in the front, it said be careful to remember to distribute or FOIL when you have a binomial squared. If you have a binomial squared, you have to FOIL it. Some people can do it straight from this spot. You don't have to write it out. If you're that person, great, do that. But if you're the person who made this mistake, x minus 5 squared, and you wrote x squared plus 25, and a lot of us did that. If this is the mistake you're making, you need to make sure you write it out every single time. Okay? Make sure you write it out. It takes, what, another 3 seconds to write that out? And now we're going to FOIL. X squared minus 5x minus 5x will be minus 10x. Negative times negative is plus 25. Equals 3 plus x squared. Now what becomes really nice about this is you have an x squared on both sides, which means if you subtract it, it's going away. So subtract x squared on both sides. That will cancel, or subtract out. Now, I personally like my x's to be positive. But I don't have another x, I only have the negative x, so I'm going to let it stay over here and be negative. I'm not really going to change it because there's not another one to change it with. So I am going to move the negative 25. I end up with negative 10x equals negative 22. Divide by negative 10, I get x equals negative 22 divided by negative 10. Negative over negative would be a positive. And I can simplify that. Divide by 2, I get 11 over 5. There we go. This one over here is very similar. Go ahead and pause the screen, see if you can multiply those two sets of binomials, and then you can unpause it to see if you set it up correctly. Okay, I'm going to unpause right here. Again, if you can get from this spot to here without writing it out, that's fine. Some of us can do that. But if you are struggling getting there and you're losing that middle term, then you want to write it out every time. So you remember first, outside, inside last, your FOIL, and you have 3x and 3x to get 6x in the middle. Here we had negative 3x to get negative 6x in the middle. Negative times negative is still positive 9. So if you're, whatever it is that you have to do to make sure that you're going to distribute those and multiply them correctly is perfect. Now I'm going to have positive x squared on both sides, so they are going to subtract out. I have a positive 6 and a negative 6x. I want them to be positive, so I'm going to add the 6x over here. But I want the numbers over here on the right then. If I subtract 9, the 9 is going to subtract out as well. So this is actually going to turn out to be pretty nice. I end up with 12x on this side equals 30 over here. Divide both sides by 12. It's not even, but I can simplify 30 over 12. It's going to divide both of those by 6. So I end up with x equals 5 over 2. There we go. Hopefully I did that right. Otherwise, check out the work. Make sure you have it written down pretty well. Now, 801 talks about solving ax squared plus bx plus c. Use your notes for help and to study. Make sure you come back to these. Make sure you study these. This page of problems is going to last throughout the year. You need to have a strong foundation with quadratics. It's not going away, I promise. How many of you remember quadratic formula? The quadratic formula can be used to solve all quadratic equations, which makes it super nice that if you can't FOIL it, or you can't solve it like these ones up here, or you can't factor it. I didn't mean FOIL. If you can't factor it, you can always use quadratic formula. It's never going to not work. Most of the time you probably heard this in a song. If you heard it last year, probably in a song. X equals opposite b plus or minus the square root b squared minus 4ac all over 2a. Look it up. Sing along. I sing it in my head every single time, and I write out like the blank ghost formula is what I call it. This b squared minus 4ac is called the discriminant, so that's why it's represented by this d over here. Anyway, we're going to do a few of these. Solve using the quadratic formula and indicate the discriminant. So generally I set this up. X equals opposite b plus or minus the square root b squared minus 4ac all over 2a. And I set it up as like a ghost formula, so I have all those blanks in there and I can just fill in the missing pieces. So remember, I set this up at the very top of the page. It was ax squared, did I just write, oh, right here, ax squared plus bx plus c. Those are the numbers that go in these spots. So I'm going to go ahead and pause and fill those in. You fill them in too and check. Okay, so I put my b's here and here. A is 1, it's a coefficient of 1 in front of there. C is -6, and a is 1. Now generally, I usually work with my discriminant first. And I say, okay, well I have 5 squared is 25. Negative times a negative is a positive 24. Add them together, I get 49. 49 squared root 49 is 7. Once I have my discriminant, then I come back to the rest of the problem. And now I'll say, okay, well I have opposite of 5, plus or minus, that's a 7, all over 2 times 1, which is 2. So this gives me essentially 2 different solutions. Right like this. Negative 5 plus 7 is going to be 2 over 2, which is 1. Negative 5 minus 7 is going to be negative 12 over 2, which is negative 6. So my 2 solutions for this problem will be x equals 1 and negative 6. Now I wanted you to solve this using the quadratic formula, but if I get 2 answers, I get 2 like actual value, like numeric answers, that means that I could have factored this. If you guys remember factoring, factoring is when I split it back up like this. I'm going to say x times x. It ends in a negative, which means my signs will be different. I would have a plus and a minus. Factors of 6 that have a difference of 5 are going to be positive 6 and negative 1. This is equal 0. So if x plus 6 equals 0, x would equal negative 6. Subtract the 6. If x minus 1 equals 0, add 1, you get the positive 1. Factoring is much easier. It's much faster, it's much easier, so if you can factor in a problem, that's what I would do. But if you can't factor it or you just don't see it, you can always use quadratic formula, but it's a little bit longer. I'm going to pause my screen. You should pause and see if you can set this one up. First, my first hint is that you need to get it set equal to 0. So you're going to add 5 over here. So really you're going to have 0 equals negative 3x squared. Oh, wait. I use a lot of whiteout. I told you that. When I use a pen, I use a lot of whiteout. Apologies. Okay. I want to get this set equal to 0, but I also want my a value to be positive. So because it's negative, I'm going to move everything over here to, my nose is tickling like crazy today, I apologize. Parakeets tickling my nose. Okay, so negative 3, I'm going to add it over here. I want the x squared coefficient to be positive. So I'm just going to move everything over to the right. So I'm going to have positive 3x squared minus x minus 5. Okay, I'm going to pause it. You go ahead and take that, set up your ghost formula, quadratic formula, and simplify all you can. Okay, so here I plugged in my b, a, c over 2a. I did my discriminant off here to the side. I got 1 plus 60. I got square root of 61. There are no perfect square factors that go into 61. So I'm not going to do anything with it. I'm just going to leave it square root of 61. So I come back over here. It's okay, well, opposite of negative 1 is a positive 1. Should be a positive 1 out here, sorry. Plus or minus root 61 all over 6, which means this also would be positive 1. Now, this is how we write it, but later on in Algebra 2, it's nicer if you have it in two separate terms. So we're just going to put both of them. All over 6 means 1 over 6, and plus or minus 6, root 61 over 6. So I'm going to write it in two separate terms. Now, this is solve using quadratic formula and indicate the discriminant. So again, you want to get this set equal to 0. X squared is already over here on the right and it's positive. So I'm going to make this 0 over here. X squared minus 6x minus 3. Okay, I'm going to pause it and I'll come back in a minute. So pause, do your work, and then come back and check. So again, right here, you want to see, can you set up the ghost formula on your own? Do you know the quadratic formula? Can you sing it to yourself? I sing it every time I do it. You can look up on YouTube. There's plenty of people singing it out there. Can you set it up? Really want to know how to set it up. This isn't going away. Make sure you can set that up and then plug them in. I'm going to go ahead and do that and show you the answers in a moment. I wanted to give you a slight intermission. If you need to list A, B, and C off to the side, you can, and then plug them in. So if that helps you to list the A, B, and C, do that, and then plug them in. Now that they're in, go ahead and see if you can simplify the rest of the way. I want to show you here I had 6 squared was 36. Negative times negative is positive 12. I get 48. 48 is one of those perfect squares we should memorize by now. We had it the other day in our notes. Square root of 16 times 3, 4 root 3. So I'm going to put 6. Opposite of a negative 6 is positive 6. Plus or minus that 4 root 3. All over 2a. So all over 2, except I want to separate it like we did up here. So I'm going to write it over 2 like that, because now I have 6 over 2, which I can simplify to 3, and I have this 4 and the 2 that I can simplify, so I can make this over here 2 root 3. So that is my completed answer. I'm going to pause again while you finish the other side. Hopefully you guys are doing well, and hopefully you guys are getting these right after a few tries. I know it's quite a few tries. Thanks. Okay, so we get this one, negative 8 squared is 64. 4 times 2 is 8 times 7, we get negative 56. Subtract, we get 8. 8 has a perfect square factor of 4. 4 times 2, square root of 4 is 2 root 2. Opposite of negative 8 is an 8, plus or minus 2 root 2, all over 2a, which is 4. So instead of all over 4, I'm going to put this side over 4 and this side over 4. 8 divided by 4 is going to give me a 2. Plus or minus here, the 2 and the 4 simplify, giving me root 2 on top and a 2 on bottom. Here's my final answer. So hopefully we did well. Good luck with those. Have a great evening.